Hi, pre-calculus students. We are going to talk about the second half of section 3.5. So we had talked about continuity. So now we're going to talk about end behavior and functions that are increasing and decreasing. So make sure you have your notes out, something to write with. Every time, you guys. Every single time. Every time. I want to share my dot cam. Okay, here we go. Okay, end behavior. Now, end behavior you talked about a little bit in Algebra 2. So we're going to talk about it a little bit more. So end behavior is when you talk about what's happening to the y values of your function as your x values get really, really big and really, really small. We did this a little bit back in chapter 12 last semester with sequences. We talked about as n gets bigger, what happens to the values of your sequence. We didn't talk about as n got smaller because that didn't make sense in that context. But now we're going to talk about it in both directions. So remember our notation back from chapter 12 when we talked about limits. So it was the limit, and now this is going to be of f of x. Instead of n approaches infinity, it will be as x approaches infinity equals, and then you're going to look at the graph or think about the function and decide what it gets closer and closer to. Now we want to do this in both directions. So we want to do it both as f of x as x approaches infinity, but also as it approaches negative infinity. So when the directions say, using limit notation, it means you're using that limit notation. Okay, so we're going to describe the end behavior of each of these functions. So we're going to talk about the limit of the function as x approaches infinity, and we're going to talk about the limit of the function as x approaches negative infinity. Now, some of these you're going to know what they do because you know your parent functions. Some of these, it might be helpful to look at a graph if it's not one of your parent functions. But if it is one of your parent functions, then you really should be able to figure out the end behavior using what you know about that parent function. So example A is one of our parent functions. It's y equals f, 5x cubed. So we know that's a cubic that's been stretched. So it's something like this. Okay, so as we're trying to find end behavior, we're thinking as x gets bigger and bigger and bigger, what are the corresponding y values doing? Are they getting bigger and bigger? Are they getting smaller and smaller? Are they going back and forth? Are they leveling off at a particular value? Okay, so in this case, as x gets really, really big, the y values are going up, 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 up. So we would say the limit is infinity. Sometimes I think with the sequences, we would say the limit did not exist. Now we'll say we'll use infinity. Okay, now here we're also thinking what happens to the y values as x gets really small. So as x travels to the left, what are our y values doing? They're going down, 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 getting smaller and smaller, so negative infinity. Okay, so for part B, I want you to stop and think about first, just sketch what that graph would be. What's the parent function? What do these numbers do? Just to get an idea, it doesn't have to be perfect. Okay, it's a parabola. This -2 means it is going to open down and it's going to be vertically stretched and it's shifted down 9. So it's something skinny and down here. So then think, as my x gets bigger and bigger and bigger, what are my y values doing? So as x gets big, 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 my y's go down, 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 down towards negative infinity. And then here, as my x gets smaller, 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 what are my corresponding y values doing? They're getting smaller, smaller, smaller. So again, we would say negative infinity. If you wanted to be fancy, you could say the limit of f of x as x approaches positive or negative infinity is negative infinity, if you notice that. So this table here kind of summarizes in general end behavior for any polynomial. And we saw a couple of examples up here. So first of all, if your power is even, like here, my power, my degree up here was even. If it was to the 4th or to the 6th, if the highest power is even and the coefficient is positive, then it means both ends open up. Now, if it were a higher degree, it might, have a couple wobbles in between or something like that, but it would mean both ends are up. So that means as you approach from the left and x approaches negative and positive infinity, both limits are infinity. Okay? If there's a negative in front, like we saw here, it's both ends down. So as you approach from the left and the right, it's negative infinity for both of your limits. If you have an odd degree, like we did here, and a positive coefficient, it's one end up on the right, down on the left. Now, if this was 5th or 7th or whatever, again, there could be some wobbles in there, but it's always going to be up on the right, down on the left. So as you approach positive infinity, it will be positive infinity. And as you approach negative infinity, it will be negative infinity. Okay, if it's a negative in front, then it's heading up on the left and down on the right. So then that flips it. So as you approach negative infinity, the limit is positive infinity, and as you approach positive infinity, the limit is negative infinity. Okay, so that's end behavior. The other thing that we need to talk about are increasing and decreasing functions. So increasing functions. So here's like our fancy description of what it means to be increasing. So a function is increasing on an interval I if and only if for every a and b contained on the interval, f of a is less than f of b whenever a is less than b. Okay, so think about like kind of what you probably have intuitively in your head for like what it means to be increasing is that as you are moving on your graph from left to right, your graph is getting bigger, right? So maybe something like this. So let's say this is my interval and this is from A to B. So you agree that A is less than B, like this said here, A is less than B. If it's increasing, then that means that f of A, so the y value associated with A, is smaller than the y value associated with B. Well, that makes sense. If it's increasing, right, it's getting bigger as you move from left to right. So for decreasing, right, something like this, if this is A, oops, hang on, it's different. The function is decreasing on an interval if and only if for every A and B contained on the interval, f of A is bigger than f of B whenever A is bigger than B. So in this case, it's saying A is bigger than B. Okay, so if A is bigger than B, then that means f of A, which is here, is bigger than f of B, which would be here. All right, and then what else? And then this is constant, it's that they stay equal. All right, so that's kind of intuitive. And so now we have a couple of examples where we're going to find intervals for increasing and decreasing. So first it says graph each function. You can do it in your calculator, determine the interval or intervals. It could be more than one. It could be none, depending on the graph, on which the function is increasing, and on the interval or intervals on which the function is decreasing. Use interval notation. That's what we talked about in chapter 1 with the parentheses or the brackets. Okay, so this function here, you can use what you know about parent functions if it's a simple one, but you could also graph it. So if I were to graph this one, it is an easy enough one. I know it's a parabola, and I know it's been shifted down 7. So it looks something like this. That's an easy enough one. So increasing, I'm going to trace in my increasing intervals in pink and my decreasing in yellow. So what I like to do is just start from the left and working to the right and think, okay, what are happening to my y values? Are they getting bigger or smaller? So as I move along the graph, my y values are getting smaller. So it's decreasing, decreasing, decreasing. It stops decreasing here at that turning point. And at that turning point, it starts to increase. So those are my intervals where it's increasing and decreasing. Now, when I name my intervals, I'm describing the x values for which the function is increasing or decreasing. So the x values that correspond to this section of the graph start here and go to the right. Now, technically, at my minimum here, it's not increasing or decreasing. It's a turning point. Okay, so it's like I have an open circle there. So my intervals for which it's increasing is from 0 to infinity. Remember, I always start with the smaller on the left, bigger on the right, always a parenthesis with infinity. And because I'm not including the 0, it's going to be a parenthesis. Because we're never going to include a turning point, these will have parentheses. Okay, decreasing. So all the corresponding x values to this are everything to the left of 0. Now, when I give my interval, remember, I always start left to right. So the smallest would be negative infinity to 0. All right, so for this next one, this is my parent function. It's a hyperbola, but it's been flipped. So instead of being in quadrants 1 and 3, it's in quadrants 2 and 4. All right, so look at each interval and think, as you trace that, what are happening to the y values as you move from left to right? Are they getting bigger and bigger or smaller and smaller? So if I start tracing this, my y values are getting bigger and bigger, so it's increasing. So for all of these x values along here, not including the 0, it's increasing. Now, I do have to jump because there's a vertical asymptote, but if I start from left to right, what are happening with these y values? They're also increasing. Okay, so this is increasing really for the whole thing, every value it's increasing for except for at 0. I'm going to write it as intervals though. So this is going to be from negative infinity to 0, and then from 0 to infinity. We can put that union symbol there if we want. And it's never decreasing. So here's an example where I don't have an interval for decreasing. All right, so then for part C, now this one, I don't really exactly know. I know it's cubic, so it's gonna have one end up, one end down, but I don't really know what's going on in the middle there. And so I wanna graph it. So you can graph that in your Inspire, or you can graph that in decimals. And I'm gonna show you both. Make a new document. And help me. I wish we could see these calculators better. All right, so 5x to the third, and then plus x squared minus x plus 4. Okay, you can kind of see it a little bit better than usual here. Okay, so I have this graph. It's some part of it's increasing, part of it is decreasing. I'm going to sketch it over here. So it's doing something like this. I'm doing this just so that you can see, because I can't trace it on my calculator here. So it goes like this, and then dips, and then it goes like that. Okay, so if I were tracing it from left to right, I would say, okay, it's increasing, increasing, increasing up until there. And then what happens there is it starts decreasing, and it decreases till about there. And then it picks up and it's increasing again. And so I need to know what these values are, because at those values, that's where like it turns. So my intervals for increasing are everything like from here to there, and then from here to here. My decreasing is everything in the middle. So I need to know what those values are. So what I'm going to do is I'm going to hit the menu key. So I'm going to hit menu, and then I am going to pick 6 for analyze graph. And let's say I want to get this point right here. That's a maximum. So I'm going to pick number 3 for maximum. And it's going to give me this little bar here. And it's going to ask for here my lower bound. So I've got 2 choices here. One is I can use the touchpad to move this to the left of where my maximum is. So I can move it like here, and then click in the center. And then it asks for upper bound. I'm going to move to the other side. And see, once you move to the other side, hang on, let me get back over here. Once you move to the other side, I'm losing it. It does, like, it pops up. Okay, so then I know that maximum is happening at negative 0.3334.26. So this value here that I want is the negative 0.333. I don't love using this touchpad because you all saw me having a hard time getting around it. So I'm going to show you another way when we do the other one. Now I'm going to pick this guy up because it's in my way. I'm going to hit control, and then I'm going to click in the middle at the same time, and then I'm going to slide it. And when I'm happy with where it's at, I'm going to click in the middle and dump it. Okay, get it out of my way. Okay, so now I want that other point. So I'm going to go to menu. I'm going to go to 6 for analyze graph. And now I want this point here, which is a minimum. So I'm going to pick 2 for minimum. Now, rather than moving this cursor for lower bound, because I'm so lousy at doing it, I'm going to just type a number in for lower bound. And I can tell that my minimum is falling like maybe between 0 and 1. So I'm going to hit 0, and then I'm going to hit enter. See, it pops. You can see it here. Do you see when I type 0? It's right there. And I'm just going to hit enter. And then it's going to ask for upper bound. And I thought between 0 and 1, I'm going to type 1, and you can see it's right there, 1, and then I'm going to hit enter. And then it will calculate a minimum for me between 0 and 1. So you can see I have a minimum at 0.2, what is that? 3.88. Okay, so now for my intervals, it is increasing along my pink. So from here to here. So from negative infinity to the x value, so negative 0.333, and then again from 0.2 to infinity. I'm only interested in the x values. The x values for which it's increasing. It's decreasing from this x value to this x value. So between negative 0.333 and 0.2 is where it's decreasing. Now, if you don't have an Inspire, use Desmos. And sometimes I think Desmos is actually even easier for this, as it is for really, I think, many things. All right, so y equals 5x to the third. Don't forget to bump down. I always forget to bump down. Minus x plus 4. Okay, so here's the thing with Desmos. I really want to know like this maximum and this minimum. You can just click on it. Bam, there it is, negative 0.33. Click on this, bam, 0.2. It's right there. I didn't have to hit all those keys. Okay, so that's 3, 5, end behavior, and intervals of increasing and decreasing.